Hello, my name is Peter Parfitt. Welcome to the New Brit Workshop. In this video I'm going to talk about probing with a CNC, that is establishing where your X, Y and Z 0 points are, your reference points are for a particular job that you might be about to start. But before I do that, I want to just show you the CNC that I've got set up. You may have seen it already, it's the 750mm X-Carve from Inventables, but in particular I want to show you some little adaptations that I've made. Right, so here's the setup. This is the X-Carve CNC itself. It's got a DeWalt writer as its spindle. That's got a 1/4 inch chuck. This is the control unit which comes with the X-Carve. They call it the X controller. Over here I've got my own notebook computer, and on this I run 2 pieces of software. In order to generate the toolpaths for a particular job, I run V-Carve Pro. And in order to send those toolpath files to the CNC, I use Universal G-Code Sender because I've got V-Carve Pro set up to produce G-Code toolpath files. Now I've brought you in to look a little bit more closely at the wasteboard on this CNC. Actually, there are 2 wasteboards. There's the original one which came with the X-Carve, which is underneath here, and then I have this piece of 10mm plywood on top. And these holes that you see in it go through to the original baseboard where there are some screw inserts which allows one to screw clamping elements into the surface to hold a job in place. Now I've made this top piece of wasteboard myself. It's held in position with 3 screws. There's one here, there's one here, and there's one in that top corner there. I've marked the tops of those screws with red so I can make sure when I'm setting up any particular job, if it's going to cut all the way through, I don't do it in those places. Now I hope you can see these 4 pins that I've got in here. What I did was, when I set up the machine and got it all squared up and I was happy, I then put in a small cutter in the machine, and I then told it to drill some holes. And I've got 4 here and 4 here. And these holes are the perfect size for this little short piece of brass dowel that I've got. Now my idea is that these then allow me, when I'm setting up for a job, to put the job into the machine and it's at right angles to the X and Y plane of the machine. I know it's at right angles because I drilled these holes with the machine. When the block comes in like that, or it might be like this, then you know it's going to be lined up perfectly with the machine. That's the start of it, and you can move these around. Now when you start a new job, you get your workpiece clamped into position, and then the first thing you want to do after that is to set the origin, the home position for the particular job. And it's usual that it's taken at level with the surface of your piece of wood in this left-hand corner nearest to the operator. So your home position would be right where the point of this V cutter is right now, just in that corner there. And if you've got a tool which is not a V cutter, it would be the center of the tool, would be right over that spot, just touching the surface of the material. Now in order to get the machine set up so it's just over this point, so I can then issue the command telling it that that point there is the home position for this particular job, I would move the machine manually. And it would be a question of moving it manually like this, using the software on the PC, until the tip of the tool is in exactly the right position. And that required me to have a bit of judgment, if it was a tool like this, to make sure it's in the center, there like so. And I would use a piece of paper and lower the tool down so it's just touching the surface of the material. And then I'd be able to set my home position. Now, after a few sessions of using that approach, one quickly gets fed up with the idea and one wishes for a better way of doing it. Well, there are better ways. I'm now going to take you through the options. Now, one of these is a solution which comes from Inventables, the maker of the X-Carve, and then I'll take you into variations of my own which go beyond that. Now, Inventables make an optional extra which they call the Z probe. It consists of a a disc of brass which is about 15 millimeters thick, and I'm guessing it's about an inch in diameter, so probably about 25 millimeters in diameter. And it's got a little hole in one side, so you can put in a little connector like this, and this is part of the kit as well. And you would then connect this connector to the X-Carve Z probe socket, and that goes to the controller, which allows the machine to sense when the Z probe is being activated. And this would go onto the spindle of the router. And the idea is that when this spindle of the router, or the tool that's in it, touches this element, then the controller over here knows that something's happened, and it can then say, oh, I've just detected that, therefore I know how deep my point of my tool is at this given time. So it's only capable of doing things in the Z direction. And the way you might use this is to set the machine up so in terms of X and Y that it's in what you consider to be the home position, and then you'd pop this underneath the tool, make sure these wires are connected as they should be, as they are now, and then you would issue the probing command. You see, what happens is the machine is now going down slowly until it makes contact with this, and as soon as it made contact, it said, right, I know where I am. It would have remembered that place, and then it would have backed off by, in my case, about 10 millimeters above the surface of the Z probe plate here. And in doing all of that, the coding which goes behind this, which I will show you, actually takes account of the thickness of this lump of brass, so that the machine actually now knows that its Z0 position is on the surface of this piece of wood. I'm showing on the screen now the little macro file which I used to do that Z probing just now. And it's being shown in Microsoft Notepad. The first command, G21, tells the machine you're operating in millimeters, just to be on the safe side. Then comes the probing command, which is G38.2. That says to the machine, right, you're now going to probe until you detect that the probe sensor has detected the probe target. And then after that, it's followed by Z-20 F60. Z-20 means go down in the Z direction for up to 20 millimeters. Then F60 says go down at a speed of 60 millimeters in a minute, or 1 millimeter a second. And then once the machine receives that, it would start moving down. And as soon as the probe hits the target, it will stop. And that's part of that G38.2 command. And when it stops, the next command comes into force, which is G92 Z-15. And what that is saying is that the position that the Z is in now is relative to the home position minus 15 millimeters. In other words, 15 millimeters is the thickness of that probing target, that piece of brass, and so the actual Z position will be 15 millimeters below it. Then after that, we close things off by telling it, right, you're going to do a move, so G91, and then you tell it G0Z10, and that combination basically moves the spindle up by 10 millimeters so that one can then easily remove the probing target. And M30 is just end of job. So that's that simple bit of coding just to use the Z probe. Well, frankly, that's all well and good, but you've still got to do the X0 and the Y0 positions in order to get this working. So for me, this isn't quite good enough. So in order to take it forward, I've got a piece of brass angle, and this is about 40 millimeters across here. I imagine the thickness is, I'm guessing, probably about 5 millimeters thick. And I've drilled some holes here, I've drilled some holes and I've tapped them, and that means I can join this together, and now you can see how it works. Basically it fits in so it's touching on those two sides there. There is a small gap of about 6 millimeters below here, and above here it's about 17 millimeters roughly. Just these are random figures. If you were to make one of these, you could choose exactly what sizes you wanted it to be. And here is a hole, and that hole allows me to connect my Z-probe lead to the original hole that's in the original Z-probe target. And now let me show you what we've got. If you imagine we've now got our corner of our piece of wood here. When I place this on that corner, because this is a right angle here, the inner faces of the brass angle now are up against the two faces of the wood, which means that if my probe were to touch this side or that side, it would know that the outer edge of the probe is flush with whichever edge we're talking about. Now, what you now need to do is to have a slightly more elaborate little macro for the probing. I've now got the workpiece clamped in position. Now, I want to keep my little target pushed against this corner. So I've got this little gadget, which is a V-shaped piece of wood, and it's just pushing gently against there. Right, so everything's set up, and I've loaded the macro file, and now I'm going to send it. First of all, it's doing the Z direction. Down it goes. It will detect that. Fine. It's now going that way in the X direction. It's detected that, and it's now coming this way in the Y direction. And that's it. That's the job complete. It now knows exactly where the bottom left-hand corner of this is. And I'll show you the code right now. Well, we're looking at Notepad again, and here's the file. And essentially, it's very similar to the first one I showed you when we were doing just the Z only. G21, that's metric units, and then it's the G38.2, exactly the same one we had before. Z-20, F60. In other words, a probe in the Z direction up to 20 millimeters at a speed of 60 millimeters a minute. And then after that, it's found that position. It then says, right, remember this, G92, Z15. In other words, the Z0 position for this job is 15 millimeters below where you are right now. And after that, then it moves itself away from touching the bottom Z target. And it says G91, G0, Z10. In other words, move 10 millimeters above where you are now. And then we're going to do something very similar for both the X and the Y direction. G38.2, X-20, F60. So move in the X direction up to 20 millimeters and at that same speed. My probing tool that I've got in the machine is a 1/4 inch in diameter, which is 6.35 millimeters. So half of that is 3.175. So my actual X0 position is over by half the diameter of the tool. And that's what that does. And then it says, right now, move it away from there by 10 millimeters. So move it back by 10 millimeters. Then go through the same process in the Y direction. And again, we have to make the correction of 3.175 millimeters when we come to telling it exactly where the home position is. And that's it. And we went then end off the job with M30, just as we did before. Now, in order to prove to you that this is the home position as I've described, let me remove this paraphernalia. I've not moved the setup in any other way. And trust me now, I'm going to issue a command that tells this to go to the home position for this job. And I think you can see now that the center of this piece of brass dowel that I've got on the machine now is sitting nicely over that corner of that piece of wood. Now, what happens if we want to do a tool change? I've moved the machine over a bit so it's away from that zero position. And I'm now going to loosen off this collet. And I don't know if you can see, I'm now moving this randomly. And I can assure you I've got no idea where it originally was. So let's pretend we've done a tool change, and I don't know whether the tool is the same depth as the old one. In fact, it's bound not to be. Now, in doing that tool change, I was very careful not to force the gantry to move either in the X or the Y direction. I was careful to do that. Now this is what you do for a tool change. I'm just going to raise this a little bit. I'm now going to put this back into position. I'm going to move it slightly to the left, get this back in onto the shaft of the machine. So that's in position now. And now all I do is run the little Z probing one that I did at the very beginning. So I'm going to find that file and I'm now going to send it. There it goes in the Z direction, finds the target, says, yep, okay, I now know my new Z position. Right, so we'll now remove the paraphernalia and we'll now see if this machine knows its new Z position because we've elongated that. So I'm going to tell it to go to the home position. There we go. So yet again, it's done it spot on. And here's my next idea, and really it relies on the fact that I've got these pins, which I showed at the very beginning, which means that my piece of work is always going to be put in the same position on the machine. And my idea is that when one homes the machine, it's going to go over to this corner here, and it's always going to go into the same place because of the homing switches. Then actually all I really need to do is to detect the Z when it's over here, because if I know how far it is from the home position to this corner, and I've measured it, and I know precisely how much it is, then I can say, right, you're in the home position, you've touched the plate which is here, therefore I can calculate how far it is to that spot there. And that's what I'm trying with this next idea. And here's what I've created to do this. It's just a piece of brass bar. It's 2.1 millimeters thick, and I'm guessing it's probably about 15 millimeters across in this direction. And this way, it's about 60 millimeters. There's a hole in it for a screw, so it can be screwed to the wasteboard. And you can see a little soldered connector there so that I can connect that part of the Z-probe kit which came from Inventables. Right, that's that in position. Now, if I get this machine to do its home cycle, so I'll go into the commands, and on the keyboard, which is just up to the left here, I'm going to do $H, which means the machine's going to home itself now. And it detects the two limit switch, well, the three limit switches. It's already done the one for the Z direction. And it's now detected the X and the Y, and it's now set itself up at the hard home position for the machine based on those limit switches. Right, now then, if I just connect up this in the usual way, so that's connected. I'm just going to manually move the machine down a bit because it makes things a lot quicker. I've got a little macro file which is going to send the machine down. It's going to detect when it hits this top surface. My little macro knows that this is 2.1 millimeters thick. It also knows the X distance and the Y distance from the home position to this corner of my piece of material. Now, the only thing one has to do with this little file is every time that the thickness of the material changes, you have to change the file. So it's sitting there above there. I've got my new homing cycle. Here it goes. And now it's detected the plate, it's raised it, and that's job complete. Now the theory is, if I now tell this to go to the home position, it should go to that corner. And there it is on that corner. Now if I change the tool, I've got to reset the Z at least. Now I could do it by doing that same procedure over here. Now the advantage of this method is that when I was using this technique, I assumed my tool was 1/4 inch in diameter, and I made an allowance for that. If the tool diameter changes, then you've got to change the file. So if I was using a V cutter, I'd have to know the diameter of the V-cutter. But with this method, all you're doing is getting the tool to hit there, and then you're doing a calculation to take the tool to that point there. Now the disadvantage is that in my little macro I've taken account of the thickness of this piece of wood in order to get it to there. Now the code for this is fairly straightforward. We start off by telling it it's in millimetres, then we do the probing command which is G38.2, and it's going to go down as much as 20 millimetres if it needs to at that speed, just like before. And then once it's hit there, it's going to then make the correction to the X from the home position, which I've already calculated is 28 millimetres, the correction for the Y, which is 30.3 millimetres, and then the correction for the Z, based on the thickness of my material, which is 20 millimetres, take away the thickness of my Z probe target, which is 2.1. And so that ends up at 17.9. And what it basically is, it's whatever the material thickness minus 2.1, and that is a minus figure, whatever that result is. After that, it's G91, G0, Z10, just to move the probe out of the way, and end of job, just like before. Well, I hope that little introduction to Z probing is going to be useful. Whenever you're writing any of these commands, etc., do take great care, because you never know, and it's happened to me one or two times, you may find the machine's trying to bury itself in the wasteboard, or it's trying to come too far forward, or whatever it might be. So make sure you've got your hand near that big red button on your CNC so you can stop everything if it does go wrong. Thank you very much for watching. Take care. Bye-bye.